Not everyone knows what they're going to do in life. You had to think about what you're doing and not just the right answers. When you get into a space that you really enjoy, that's not the only thing out there. In essence, it's all problem solving.
Welcome to EGR Pod, where engineers tell their stories. Today I'm talking with Olive, who is a manufacturing engineer at Cummins. She received her bachelor's degree in mechanical engineering and then a master's in manufacturing engineering. Thank you for being here today, Olive.
Thank you for having me.
I'm hoping you can start off by telling us a little bit about why you went into engineering.
Yeah. First of all, thank you so much for this opportunity. It all started when I was young. My father was into cars. He liked working on cars, and I liked to be around him. So anything that he touched, I always wanted to touch. My brothers as well. So would always talk about cars in the house. And I just got inspired. So that was in primary school. So in Africa, we have primary and secondary school. So that was in primary school. And then when I transitioned into secondary school, my school actually offered mechanical technology. So I could take that for 3 years. So that's 10th grade, 11th, and 12th grade, along with other classes like physics and mathematics. So I decided to go that route. I was like, what is there to lose? I just went to class, took my notes, did practicals. We had practicals in theory. And for some reason, I really understood what I was doing because I really enjoyed mechanical technology. I look forward to that class every time. And I've gained the teacher's favor. Her name is Miss Likalakala. Shout out if she'll hear this podcast one day. Very good teacher. And she really broke down what mechanical technology was about and, like the design phase and how that goes into us actually creating the product. I think my first project was to create a toolbox. So they'll give you like a case study. So you have to come up with a way to meet that problem. Your dimensions have to be within the specifications and all of this. So I really enjoyed it. Then after that, I graduated high school. And before I could graduate, my aunt had already extended an offer to come and study in the US. Had I stayed in South Africa, I was going to pursue flight school or I was going to go do zoology. I was all over the place. But then in my head, I said, God, if I go to the US, I'm going to pursue mechanical engineering and I'll not quit. And that's what happened. I ended up coming to the US and fast forward to Nova.
I didn't know all of that history that your father inspired you, and then you had all of
Yeah.
those opportunities along the way. So I want to hear about your time at Nova. Can you tell us how it compared to that mechanical technology that you'd had at home? Was it a seamless transition or was it different, easier, or harder?
Oh, that's a good question. So back home, we actually had started taking classes in calculus. We had started doing derivatives. And I used to enjoy it. I was like, I don't know about this, derivative subject, part of the whole class of math. But then I'm willing to learn. And then we only touched a little bit. Fast forward to Nova, I got placed because you have to take a placement test. And math was my strongest. I really enjoyed math. So I got placed into Calc 1. And usually you go into pre-calc before you can go to Calc 1. Taking calculus helped me understand that, oh, there's another side to derivatives. You can actually derive something and then also integrate it to come back. And I saw that also happening in my engineering classes. It's not just, oh, I'm learning math. I can use the math I'm learning in my engineering classes. So I could make those connections. And what I really enjoyed was that we had projects. It wasn't just like, okay, you come to class, you take notes, you write your exam. But we actually had projects, and one of which we created a solar panel tree to charge something. It kept me thinking that engineering is not just in the classroom, but you can actually apply it to make something that can be used by many people. It's being able to meet someone else's need, like that case study that we had back in high school where you're trying to create a toolbox for this machine shop. And then now you're creating the solar panel to help meet a need. So I think it's always been having a problem and then using engineering methods to try and meet that problem.
I remember that solar tree project. So you stayed 2 years at Nova, or did you transfer before the associate's degree?
Yes, I did 2 years and a half.
Did you feel that Nova prepared you for your four-year institution? Do you have any memories from that time at Nova that stand out besides the hands-on fun things that we did?
Yes, I really feel that Nova did prepare me. When I took my first calculus class, it was intense because although I got placed into it, I had to study, and our professor challenged us to really understand what each concept was about. So when you look online, when you do derivatives, you can derive x to the power 3, right? And just find that to be 3x squared. But he didn't come up with questions like that. You had to think about what you're doing and not just write answers. That helped me understand that I can go and get tutoring and be able to get my homework done on time and also get good grades in the class. By God's grace, in the end, I ended up with an A in that class. And I feel that that helped me understand my physics as well. I had to apply that same methodology of, okay, if I don't understand problems, the teachers are always willing to help. That's one thing I really enjoy about Nova, is that the class sizes are very small. So for as long as you're diligent as a student and you're willing to learn the subject and really get good grades, you can either work with your teammates in the class and ask questions from your professor. And that's what I did. That's what I did throughout all my classes. Anytime I didn't understand from the textbook, I'll highlight it, ask either my professor, tutoring, prepare that way. And then also apply myself when taking exams. And sometimes it was challenging. Some of the concepts, I didn't get them enough before my exam. So sometimes I didn't get good grades in that sense. But just applying yourself really helped me. And I saw that same attitude happening when I transitioned into my four-year institution,
which was University of New Mexico. Tell us a little bit about how you chose University of New Mexico.
Oh, that's a good one. Initially, I picked Virginia Tech, so I'd applied and they accepted me. But because I was an international student, I couldn't afford $40,000 per year tuition. So then I kept doing some searches, like which schools would be best for me, since engineering school can be expensive. And that's one of the reasons why, too, I came to Nova, because it's very affordable at Nova as an international student. My aunt encouraged me. She's in radiology, so she wanted to explore more about radiology in New Mexico. And she did some digging and she was like, they have a school there too. It's called the University of New Mexico. And in my head, I was sold out for Virginia Tech. I didn't know how I was going to go, but I really wanted to go to Virginia Tech. And she encouraged me. She said, just go ahead and apply. You never know. And little did I know that the University of New Mexico had a scholarship paying 70% of their tuition so that you only pay 30%. That's for 2.5 years. So I did 2.5 years at Nova, and I need 2.5 years at UNM to get my bachelor's degree. So why not apply? So then I applied. They emailed me back saying that it was possible for me to come and that they would honor that scholarship. I decided with my aunt that, this was the place for me to go and pursue my schooling. And plus, remember how I mentioned that I really like cars because of my family. They also had, in the 4th year of the mechanical engineering bachelor's degree, the student could pursue the end of year project on FSAE, race car design, or they could do just a regular project. So I was like, I want to do the race car design because I've always liked cars from a young age. And Nova, just doing those mini projects here and there, no matter how small they were, it helped me in the long run because we ended up building a big car that ended up going to competition.
I love the fact that cars are sort of what brought you to engineering. And then in your senior year, you had the opportunity to return to working on cars. So you're at University of New Mexico and you're pursuing mechanical engineering. Are there any lessons or experiences from the classroom or from the university environment that if you could, you would go back and share with yourself as a high school student?
So during my time there, I learned that to be disciplined is very important. At Nova, you don't have to stay on campus and you can commute from there to your house every time. But in a university setting, it's different. People can stay up till late and you can stay up either doing your coursework or you can stay up just hanging out with friends. So I had to be more disciplined if I was trying to gain good grades. And then I also had to make sure that I'm well prepared before I go to any exam. So that means studying, writing notes, asking questions. I still have time to go and study and prepare for the exam. And if I'm preparing, I'm teaming up with people that know more about the subject than I do. Because best believe in any class, there's always someone who knows more about what's being taught. So rather than keeping yourself in a shell, that's what I like about our classes, even at Nova, right? When you just mingle with friends, network, you now understand what the other person's strengths are and weaknesses are, and then gather up in a group that way to prepare. And then also time management is very important because you get a syllabus at the beginning of each year and the professor makes it clear to you when each assignment is due, when the exam will be. But then let's say exam is in November and you're still in August. The idea is, oh, I'll put it off, like procrastinate till the week before my exam, which I believe if I was younger, I would tell myself, don't have that mentality of I'll put it off. Instead, when that mindset comes, start studying that time. Because you always think you have time up until that day approaches, and you always feel that, oh, I could have studied more and even gotten a better grade. And that has happened in several classes, and it's something that I would tell my 15-year-old self. And then also, it's important to work on your delivery. You're not only studying, you're not only writing, but you're also communicating with your professor. You can think of your professor as your boss. You're preparing for the outside world because school is a different ballgame compared to the work life outside of school. And I believe that when your instructor tells you this is this assignment that I need you to get done, really put your all into it and present it in a way that they'll also appreciate it. So even if you're very good at, let's say, mathematics, you don't just scribble down numbers or come up with a solution and box it and then present it that way. But you present it in a way that your instructor would understand because they're the ones marking the paper. In the same way, in the workforce, your manager expects you to deliver good results. You're not just coming up with different numbers and then expecting him to understand, but you're walking him through the step-by-step process on how you got to that solution. That way, him too can feel confident in sharing that information with the rest of the team. In college, you don't really realize how impactful your work is because you're just trying to get good grades so that you can just get to the next class. When you start having this habit in school, it will help you a lot when you get to the workforce because that information is what your manager will provide to other functions of the company. And then as a company, we are all working as a whole to meet that common goal. So that's the same thing in school. The common goal is for us to graduate. That's what everyone is trying to do. But we have an instructor to help us get to that graduation. And then in the workforce, you have your manager to help you to get to that next stage of promotion or helping out your company get to that next stage of recognition. So it's all a mentality that I should have learned when I was still in high school, even in college before I got to the workforce. It's just how you approach every activity that you're given. So discipline, being able to prepare, being able to manage your time wisely, and also being able to deliver well. Those are the things that I feel I should have learned earlier on.
And when you came out of undergraduate, did you feel fairly confident that you knew what was going to happen next? Did you know you wanted to go to graduate school or did you consider going straight to industry?
Yeah, so when I was in college doing my bachelor's, I was very involved in community work on campus, especially in the engineering student building. And it was a career expo that I went to. And that's where I met Cummins. So I interviewed with Cummins for an intern position. It was a manufacturing intern position. And by God's grace, I ended up being selected. And I went to Columbus, Indiana for that summer to understand what manufacturing was all about. Came back to school. And then that got me thinking, oh, this is what the work world is really like. I had a whole different mindset of what it was going to be like. You know, there's expectations that you have to meet. So then that helped me to start building a foundation. If I'm taking classes, this really matters. It's not just going to stay in this room. One day it will help someone else. So then I came again to Cummins at a different plant this time. This was more of a manufacturing plant. And I got to understand how the processes work. You know, it's something that you don't really see in college where systems are communicating with each other. They're pick lights. You don't just use any part to build a turbo. In this case, it was a turbocharger that the line was building. Everything has to be labeled. Each pick light has to go at the right time. So you can kind of see the different types of majors that people could go into So if you're interested in like the pick lights type situation, that would be computer science, maybe controls engineering, electrical engineering. And then the manufacturing side will be more of the process. Like, do we have the right failure modes in place? And then also, if you're interested in the industrial engineering of things, we'd see the operation side. Like, are we making parts quick enough? Are we meeting the throughput? Like all of these things. And I was thinking to myself, I wouldn't have known this had I just been in college, or even if it was taught to me, it wouldn't make sense because I'm not applying it. I kind of feel that that's how being in school and being able to intern helped me create such a foundation in the workforce today.
So the internship was while you were getting your graduate degree or before?
Yes, so I did it before and then while I was getting my graduate degree. So I got advice. That's another thing. Your managers, while you're interning here at Cummins, they're actually your mentors. So he mentored me and he was like, if there's anything I can share with you is if you're already interested in getting your manufacturing master's degree, go ahead and do it. You can still come back and intern. So that's what I did. I went and did my master's and then came back that summer to intern while I graduated the next summer to begin work with Cummins.
Can you tell us a little bit about what a typical day looks like for you? Is there a typical day at work?
Okay, so usually I'll create a list of my action items that day. And then I also have a task tracker on my Excel spreadsheet. So it tells me what type of projects my manager is expecting me to complete. They have deadlines. And then what I write on paper are the action items. Like I still need to call this person. I need to make sure that I make a purchase of this. That way, everything's going along and I still meet the deadline. But then as a manufacturing engineer, many times you come up with this whole beautiful plan on your paper and it only takes one call to throw your whole day on a different tangent. It could be, oh, such and such a machine is down. So then you have to come down to the floor and understand what it is. In some cases, when I was in Memphis, Tennessee, as a manufacturing engineer there, it would be like machine failure altogether. So then you need to first troubleshoot and understand what the problem is, and then work with maintenance. Maintenance is going to help, or technicians work on the machine such that it comes back to working condition. But as a manufacturing engineer, you're more of the person who diagnoses the problem and tells the manufacturing technicians, and then they're the ones who will fix the problem. Sometimes as the ME, you can also fix the problem. It just depends. As an ME too, you can work on safety related projects. So let's say this lathe machine is now creating so many chips. And depending on the quantity, they can either cut the person's finger. So do we get different gloves? Do we adjust the feed rate? What do we do? So you come up with different options in which you can solve that problem. But it's not necessarily just machine related. It could be from a safety perspective. It could be from a material perspective. In essence, it's all problem solving. So you can come up with a whole list of how you're going to work on the projects that you assigned that day, but then that can change. And your manager is still requiring you to meet the deadlines.
It's very time sensitive as well, right? Because
Yeah.
the line has to keep moving. So that's the
Yes.
priority at that moment.
Yes. Yeah, you cannot keep the line down for a long time. Even a minute is costly.
I know that Cummins manufactures engines for ground transport, but is their scope larger? I'm not sure our listeners are going to know what Cummins does.
Oh, yeah, yes, I'll be happy to explain. So, we manufacture diesel engines for on-highway. That's pickup trucks, the Dodge Ram pickup trucks that you see. We have those in turbo diesel. So any that don't have the Cummins logo on them, those are gasoline, so we don't make engines for those. And then we make engines for semi trucks. So we have the DAF, we have the international, different types of semi trucks. And then we also make engines for natural gas engines, actually, for school buses. And then we've been doing some demo transportation in the West Coast with hydrogen fuel. On highway, there's a lot of work that's being done in that space. And then we are also off highway. So things like marine, we make engines for boats. We make engines for locomotives. Those are the big engines. They're the 95-liter engines. It's a wide scope, but that's considered off highway. And then anything that's on highways, anything that goes on the road. We also make components. So right now I'm in the components business, and that is anywhere from turbochargers, filtration, aftermarket treatment, different segments. So we have different business units. We have the engine business that deals with on-highway and off-highway, and then we have the components, and then we have distribution, of course.
You're still pretty early on in your career, but personally, are there things you would have done differently?
Yeah, I think sometimes when you get into a space that you really enjoy, that's not the only thing out there, if that makes sense. So I think for me, I had like tunnel vision from the very beginning. It's mechanical engineering or nothing. And then when I got to the US, by God's grace, I graduated. And then all of a sudden, it's manufacturing engineering, getting to Cummins, which I really love Cummins, and then get into manufacturing engineering when there's so many different functions within Cummins that I can also branch into and add on to my expertise. So I think if anything, that's what I would have done differently, to say that, oh, I'm planning my next role in such and such function. That way I can learn more about the business and be able to coach someone else. Maybe even bring that knowledge to this podcast for someone who may be interested in coming. So in that sense, I think growth is important, and that's what I'm learning. Manufacturing engineering is really nice, but growth is also important. There are areas like finance that also tap into mathematics. There are areas like drafting and design that tap into CAD. So all of those things play a big part, in just opening your mindset to learning them and excelling.
This story has just begun for
Yes.
you.
Yeah, it's just begun.
You've given us so many words of advice and the lessons that you learned, which are
Yes.
so pertinent to everyone. Is there any last bit of advice or memory or anything that you want to share with our listeners?
Yes. I just want to share that, not everyone knows what they're going to do in life. They have that clear mindset of, I'm going to end up doing this and I'm going to be great. And it doesn't really work out like that for everyone. Sometimes, like in college, if classes are difficult, which I had my challenges in my sophomore, in my junior year, even in my master's, I had challenges. I had to come up with and defend my thesis. Something that if you have not built up the discipline from the very beginning can seem overwhelming. So I think that at any stage in your life, you need to continue to keep count, like keep a checklist. Am I doing this? Am I doing that? Do I have the right people around me? Because in college, it's very easy to get swayed in the wrong direction when your goal there is to get a degree, but get a degree while you've learned something, while you can use that information to help someone. Keep an open mind and understand that failure does happen sometimes, but you always have to get back up and keep trying. And also, our instructors have our best interests at heart. No matter how difficult the exams may be, they have our best interests at heart. And it's only us applying ourselves.
I am so happy we were able to talk today. I am so impressed by all of the things you've done, and I'm excited to know where you go from here. So thank you so much, Olive, for taking the time today and for sharing your memories and your experiences and your advice with those who are coming after you.
Thank you, Professor Lord, for having me.
And thank you to our listeners. This podcast is produced by Nina Lord and supported by Northern Virginia Community College. For information about engineering at NOVA, please visit us at nvcc.edu or on Instagram at EGR_AT_NOVA.